If 1 factorial is 1 and 2 factorial is 2, what's the value of 1.5 factorial? And in case you're not familiar with what factorials are, 4 factorial, for example, is 4 times 3 times 2 times 1. So multiplying numbers all the way down to 1. So it seems weird to ask what 1.5 factorial is, but if it did exist, we'd expect its value to be somewhere between 1 and 2. And we also expect it to follow the key law of factorials, which is this, that x factorial is x times x minus 1 factorial. For example, if I had 4 factorial, that is equal to 4 times 3 factorial, which makes sense because 3 factorial is 3 times 2 times 1. Now actually there is a function which does give us the expected result when we use whole numbers factorial, but also works for negative numbers, decimals and complex numbers. And it's this. It's known as the gamma function. And we have to use this integral here. In fact, it's known as an improper integral because we're using infinity as one of the bounds. Now, annoyingly, the gamma function is offset from the factorial function by 1. So for example, if we wanted to find 4 factorial, that's gamma of 1 more than it, which is gamma of 5. But conveniently, because this is t minus 1, we end up with the integral of x to the power of 4 e to the minus x dx between 0 and infinity, where you can see that this number here matches the power of the x there. Now, long story short, you could evaluate this integral by using integration by parts, which you might have learned before. But it turns out if we do, say, for example, 3 factorial, which is the integral between 0 and infinity of x cubed e to the minus x dx, you end up with this, minus e to the minus x cubed plus 3x squared plus 6x plus 6, evaluated between infinity and 0. Now, it turns out when you sub in these bounds of infinity and 0 into this, you'll just end up with only this last number here. And what is the pattern of these terms here? Well, if you start with x cubed, because we've got 3 factorial, if you differentiate that, you get 3x squared, differentiate that, you get 6x, and differentiate that, you get 6. Now, whenever you differentiate a power of x, you times by the power. So you times by 3, then you times by 2, then you times by 1. So this number here must be 3 factorial. That's why it works. Now, what therefore is 1.5 factorial? 1.5 factorial would be equal to the integral between 0 and infinity of x to the power of 1.5 e to the minus x. Now, unfortunately, because this is a fractional power, it turns out that this is not integratable, so we're not going to get an exact solution. But we can use numerical methods like the trapezium rule, for example, to approximate the solution. And if we do, we get approximately 1.32934, etc., etc. So that is 1.5 factorial.